Hi students, in this video we will be solving question number 30 from exercise 5.1 of continuity and differentiability chapter. This is a chapter from 2nd PU syllabus. The sum I am going to solve now can be asked in part E of Karnataka PU board exam in question number 49B or question number 50B, because the question number 49 and 50 will have A and B as two questions, that is 6 plus 4 marks. 4 marker question is always asked from continuity topic, so this can be a possible question. So please do look into the sum, understand and learn the sum. Question number 30 goes like this. Find the values of a and b such that the function defined as f of x is equal to this is a continuous function. Now, we have to find the values of a and b. We have a and b here. We have to find the values of a and b when the function is continuous. In this question, they have not specified for what value of x the function is continuous. This means the function is continuous throughout the domain of this function f of x. Sometimes they specify at a particular point that the function is continuous. Let us understand how the function is defined now. Look at this. When x is less than or equal to 2, the function is 5. That is, it is a constant function when x is less than or equal to 2. That is, whenever domain element x takes the values less than or equal to 2, the function is a constant function. That is, f of x is equal to 5. Now, between 2 and 10, that is, you can see a strict inequality. That is, whenever x is greater than 2 and less than 2, the function takes the form f of x is equal to ax plus b. This is the form the function takes. Between the values of this, between 2 and 10, whenever x is between 2 and 10, the function is like this. Okay, now the moment x takes the value equal to 10 or greater than 10, the function is defined like this, that is as 21, which is again a constant function. Whenever x is less than or equal to 2, it is a constant function. Here throughout it is a constant function, but the value is f of x is equal to 5. Whenever x is greater than or equal to 10 throughout the domain, the function is again a constant function, that is f of x is equal to 21. Between 2 and 10, the function is of this form, ax plus b. Is this clear now? Have you understood how the function is defined? Yes. Now, to find the value of a and b, we have to evaluate the limit, consider the condition LHL is equal to RHL is equal to f of a, like that, correct? Now, at what point are we checking the limit? Look at this. Function is changing the behavior at 2 and 10, correct? Whenever x is 2 or whenever x is 10, the function is changing the behavior. Between 2 and 10, it is like this. Less than 2, it is like this. Greater than 10, it is like this. It is changing the behavior at 2 and 10. So we will evaluate the limit as x tends to 2 and use the condition of continuity. Again, we will evaluate the limit and use the condition for continuity as x tends to 10. So at these 2 points, let us evaluate the limit. By doing that, we will find the values of a and b. Okay, till now, I hope the things are clear. Now, when I have to evaluate the limit as x tends to 2, that is when the domain element is 2, when we evaluate the LHL as x tends to 2, that means we are approaching 2 from the left hand side of 2. So it is very close to 2 but less than 2. So which function are we going to consider when it is x is less than or equal to 2? It is constant function, that is this x equal to 5 is what we are going to consider for LHL when we are evaluating the limit as x tends to 2. Now, for RHL as x tends to 2, what are we going to consider? For RHL, again, it is very close to 2, but little more than 2. So, it is here, very close to 2. So, which is the function? When x is greater than 2, it is f of x is equal to 2x plus b. That is what we are going to consider for RHL. When we say x is greater than 2, it can be greater than 10 also, right? But this x tending to 2, this domain element will not go to any of these points or beyond 10. It will be very close to 2 only. So between 2 and 10, there is no scope for confusion for us to consider a different function. Between 2 and 10, it is here only. So this, in this range, This is how the function is defined. So when I'm evaluating the limit for LHL and RHL as x tends to 2, so it is these two functions that I'm going to consider. So to evaluate the limit at as x tends to 10, so what will be LHL? LHL will be this for the function x tends to 10 minus. So x is less than 10. So I'm considering this function for LHL. When x is greater than 10 for RHL, I'll be considering this function. So at 2, when I check the continuity, I'm considering these two functions. When I'm checking the continuity at 10, I'll be considering these two functions for LHL and RHL. Is this clear? So the function is continuous at x equal to 2. Throughout the domain it is continuous. For x equal to 2 also this function is continuous. When the function is continuous, this is the condition. LHL is equal to RHL is equal to f of a when x is tending to a. Let us apply this condition. LHL is equal to RHL is equal to f of 2. That is limit of f of x as x tends to 2 minus is equal to limit of f of x as x tends to 2 plus is equal to f of 2. So first let us find f of 2. When x is equal to 2, the function is f of x is equal to 5. So f of 2 is 5. LHL is equal to limit of f of x as x tends to 2 minus equal to limit of 5 as x tends to 2 minus is equal to 5. Now this is a constant function. So LHL is equal to 5. RHL is equal to limit of f of x as x tends to 2 plus is equal to limit of ax plus b as x tends to 2 plus. So for RHL we are considering f of x is equal to ax plus b because x is little greater than 2 but very close to 2. So we are considering this. So for RHL we are substituting for x as 2 plus h where h is a very small positive quantity and h is tending to 0. So since there is no indeterminate form, we are substituting h as 0. So RHL is equal to a into 2 plus 0 plus b is equal to 2a plus b. So equation 1 will be LHL is equal to RHL is equal to f of 5, right? So we are substituting that because LHL and f of 5 both are equal to 5. I am writing only once. So it is 2a plus b is equal to 5. We have got a linear equation now. I am calling this as equation 2. So when we evaluate the limit as x tends to 2 or when we use the condition for continuity at x equal to 10, we will get one more linear equation like this. We will solve both the equations to get the value of a and b. So now given the function f of x is continuous at x equal to 10, we are using the condition LHL is equal to RHL is equal to f of 10. Now limit of f of x as x tends to 10 minus is equal to limit of f of x as x tends to 10 plus equal to f of 10. First let us evaluate LHL. Limit of f of x as x tends to 10 minus. So whenever the value of x is between 2 and 10, the function is defined like this. When it is LHL, we are substituting this as 10 minus h. Limit of a into 10 minus h plus b as h tends to 0. That is a into 10 minus 0 plus b. That will be 10a plus b. Now we are evaluating RHL. Limit of f of x as x tends to 10 plus equal to limit of 21 as x tends to 10 plus, that is equal to 21. So this is a constant function. So when we say x tends to 10 plus, that is evaluation of the limit when x is greater than 10 but very close to 10. This is 21. So f of 10 is equal to 21. So f of 10 and RHL both are equal to 21. So we'll use the condition for the function to be continuous. Then we get 10a plus b equal to 21. We had already got a linear equation and this is another linear equation. We will solve equation 2 and 4. You solve the equation, then b gets cancelled and we get the value of a to be 2. Substituting the value of a in equation 2, we get the value of b as 1. So the values of a and b are 2 and 1 respectively, for which the function is continuous. The function is continuous when a takes the value as 2 and b takes the value as 1. If you have any doubt, please do mention it in the comment section so that I can help you in understanding the sum.